Today we're going to look at transformational geometry, and we'll end our discussion with specifics on translations. First, let's consider what is an isometry. An isometry maps one figure to a congruent figure. The size and shape of the figure is not changed, only the ending location or position is changed in an isometry. And the image is congruent to its pre-image. In these pictures, the pre-image is the original picture, it's in black, and the image is the blue figure which has been changed. It's been transformed. This one is a translation because it's been shifted to the right and down. The middle transformation is a reflection, reflected across line segment AD. And the third transformation is called a rotation. Let's look at reflections. This is a transformation where the pre-image is reflected across a line which is called the line of reflection. So here is a reflection across the red line of reflection. In a rotation, this is a transformation about a point, such that every point and its image are the same distance from the point of rotation. Keep in mind, a rotation will always include a point of rotation and the number of clockwise or counterclockwise degrees. Finally, a translation or slide shifts a pre-image, shifts each point of a pre-image the same distance and in the same direction. On a coordinate plane, a horizontal shift is a change in the x coordinate, while a vertical shift is a change in y. Let's see if you can identify these isometries. There's one of each that we just discussed. The first one on the lower left, this is a rotation. This figure has been rotated clockwise about point R. The middle transformation is a reflection, reflected across line FH. And the last one is a translation. A shift up and to the right was made. Let's look at translations now. What if we translate this square, A, B, C, D? We'll call this the pre-image. If we were to shift this 5 units to the right, what would the image A prime, B prime, C prime, D prime look like? And what would its coordinates be? Here's the image, and the coordinates would only change, the x would only change, the y would stay the same. So that's when you translate in one direction, or one dimension. What happens if we translate in 2 dimensions? Here we have the vertices of triangle XYZ, which were given. I've graphed triangle XYZ for you. And we're asking you to shift this triangle 5 units to the right and 4 units up. So there's the image triangle, and you will see that the coordinates of the image have changed by just adding 5 to the previous x coordinate and adding 4 to the previous y coordinate. Okay, now we've studied vectors recently, and we can also perform translations under vectors. So here's a square ABCD. If we want to find the image of this square under a translation vector whose component form is 2 in the horizontal, 3 in the vertical, this is what the image would look like. The entire square has been shifted 2 to the right and 3 up. All right, here's a real-life problem. Computer animation actually involves the very thing we're talking about, translations, and also the other types of transformations. But here's a character in a new animated movie, and it will move from the point 4, -5, first to the point 16, 3, and then to 13, -2. So really there's 2 vectors that the animators need to apply. The first vector, if you look at your x coordinate, you have to add 12 to the x, and then you have to add 8 to the y. So here's your first translation vector. Now to go from the point 16, 3 to 13, 2, we've actually shifted 3 to the left, so that's -3 in the x direction. And then we've shifted 5 down, so -5 in the y. So that's a little bit about transformations and translations.